Dead reckoning is a calculation we perform to predict how far you will move in a certain amount of time at regular intervals so that you can effectively track your progress along a track line. It is just the practical application of the short distance ETA problems that we were doing before. And if you remember from that video, the most common unit of time that we use for dead reckoning is 6-minute intervals, because you can very easily convert the distance you travel in 6 minutes to your speed, because it's just 1/10 of an hour. Therefore, however fast you move is just 1/10 of your total speed. In this problem, we said that we're going 15 knots. So you could then say to lay out DR positions along this track line until you reach waypoint 1. And because of our position, and like I said, it's most common to use 6-minute DR fixes. Let's say we're laying out 6-minute DRs along this track line. So how far would you move in 6 minutes at 15 knots? It's surprising how often students will get like almost paralyzed at this because they think they have to do a lot of complicated math. It's not complicated at all. Remember, just divide it by 10. 15 divided by 10 is 1.5. So in 6 minutes, you will move 1.5 miles. So what that means is at 0800, if you were here going this way, you could reliably expect that 6 minutes from now, you will be 1.5 miles down the track in this position, wherever that ends up being. And you can mark that in advance. So the way you do that, let's come to our latitude scale and measure out 1.5 miles. Start here at just any convenient location. You can start here, it doesn't matter. And then adjust your dividers until you get to 1.5 right there. So that's 1.5 miles. You come here, you place your first prong or tine right on the 0800 fix, and your second one on the track line right there. Just really quickly mark a little tick mark. Okay, that is where you will be in 6 minutes. At 8:06, you will have gone 1.5 miles to here. Now, a DR position has a very specific notation. Just like a GPS fix has a square box around it, and a waypoint has this little circle thing, a DR position is marked by first a little tick, and then a half circle shape, like that, and a time. And the time, instead of being written horizontally, like we did here, it will be written diagonally, relative to the track line. So you can write 0806. And the reason why it's important to write it diagonally instead of horizontally is to make it clear that you are not here and this is in the future. This is where you should be. You're expecting to get over here. You know you're here, but you're expecting to be here at 8:06. Now, where are you expecting to be at 0812, another 6 minutes from now? Well, you're going to go the same exact distance, right? It's still an interval of 6 minutes. So you can measure out a new distance off of your 0806 DR position to right here. Mark that as a DR position and then label it 0812. And now you know I should be here at 0806 and here at 0812. You should do this all the way down your track line, as far as you need to go. So there's one. You could continue to do this, measure it again. 0818. And then look at this. This is always fun to do. There's 0824. 0824. But now this distance here, this distance, you can't go another 6 minutes because another 6 minutes would have you missing your waypoint. But you should know how long it's going to take you to get to your waypoint. So you also want a predicted time of reaching this one. So you could now work backwards. For these DR positions, you started with the time you knew it was going to take you, and then measured out what distance that would take you, and that was able to get your position because you also knew your speed. In this case, we know our distance right there, however long this is, and we know that we're going 15 knots. So we can predict how long it's going to take to go that far. So first you have to measure what that distance was, put it up against your distance scale. You get 0.7, so 0.7 nautical miles. So this distance here is 0.7 nautical miles. You are moving at 15 knots. So how long is that going to take you? Well, that's not necessarily an easy problem to just do in your head. So you're allowed to use a calculator for that. So remember, 60 D Street. 60 times your distance is equal to your speed times your time. So we'll do 60 times a distance of 0.7, and then apply that to speed times time. So in this case, you would now do divided by speed equals time. So you divide that by your speed of 15 knots, you get 2.8 minutes. 0.8 minutes is like 50 something seconds. That's not really an important, I think it's 48 seconds. That's not that big a deal. So you can round that to 3. So you can say it will take you basically 3 minutes to get from here to here. So if this happened at 0824, you can predict that you will reach waypoint 1 at 0827. I marked the time at a different angle here because we're changing course. So now diagonal relative to the course would be going up this way. And then we continue on track along this new track line. Let's say once you reach here, because you're so far from land at this point, your captain decides you're no longer in restricted waters. So now we're going to use 15-minute DR positions instead of 6-minute DR positions. Okay, so now you need to know how far you're going to go in 15 minutes. Take your calculator. You know you're going 15 knots. And you know you're aiming for 15-minute DR intervals. You do 15 times 15. You divide that by 60 because 60 D Street. 3.75. So your new DR positions should be 3.75 miles apart from one another. Come back to your distance scale. Measure out, here's 3 miles. Here's a half a mile, 0.6, 0.7. You can do just halfway between 0.7 and 0.8. And that's 0.75. Bring it back here. There. There's your next DR position. It's 15 minutes away, so from 0827 plus 15 minutes, that would be 0842. Yeah. And that is your next DR position. The way this usually works is DR positions happen at more and more frequent intervals the closer you get in towards land, because when you're close to land, you need to be constantly monitoring your position, and so you want to take fixes and compare them to your DRs as often as possible. As soon as you get further away, you can spread that out, make it a little easier for yourself, and only check relatively infrequently. That'll eventually expand out to 30 minutes, and then if you're open ocean, you can set your DRs for every hour. So here, you could do 0842, and I stopped the line there, but if you continued your trek out plenty far, you could plot many more of these.